Securing file servers. So far in these Windows 2008 security videos, we've talked about securing a lot of critical server roles, but equally important are your file servers, which more often than not will be where you store your confidential data that you neither want to risk losing or falling into the wrong hands where it could be used against your company for financial gain or simply to cause your company damage or embarrassment. Now, like with most of the videos so far in this series, again, we're able to utilize a server core build to reduce the attack surface of our server, and this build works great as a file server as well. Now, although we're not going to build a server core installation here in this video, as we'll cover that in a later video, if you're dying to run ahead and build a lab box to test for yourself, we've also included a list of the common commands that you'll be using to administer your server core file server, so go ahead and take a look at them. Like with earlier versions of Windows, file sharing is handled by the Server Message Block Protocol, or SMB version 2, which is an extension of the Common Internet File System. Since SMB provides the basis for file and print sharing and other network operations, it's important that this is as secure as possible, so Microsoft configured SMB to support digitally signing packets to prevent them from being modified whilst being sent to the destination, using what's known as a man-in-the-middle attack. Now, in normal communication, a client will access the file server directly to get the resources that it needs. However, when the exchange between the client and the server is compromised, the man-in-the-middle attack tricks both the client and the server into thinking that they're communicating directly with each other, when in fact that they're actually communicating with the attacker's machine that's intercepting all of the traffic between the two hosts. Now, by default, Windows 2008 domain controllers are protected against these man-in-the-middle attacks by requiring data sent between the two hosts to be encrypted. But for anything that isn't a domain controller, by default we won't be encrypting it. So we'll go and click on Start, we'll go to Administrative Tools, and then we'll launch the Group Policy Management console. And then we'll expand our forest, and then domains, and then our domain, winstructorlab.com. And we'll expand domain controllers. And if we right click on our default domain controller policy and then choose Edit, this will fire up the Group Policy Management Editor. And under the Computer Configuration heading, we'll expand Policies, we'll expand Windows Settings, Security Settings, Local Policies, and then we'll choose Security Options. Now on the left-hand side of our console, we'll scroll down and we'll locate this policy here, Microsoft Network Server, digitally sign communications always, and you can see that that's enabled by default for our domain controllers. But if we were to decide to configure this policy for our file servers, then we'll need our clients to support it, or they won't be able to contact our file servers. This means that you will need to be running Windows 2000 clients or higher, but the upside is that you probably aren't using client operating systems that are older than that anymore. And secondly, it's much more secure and prevents man-in-the-middle attacks. But because of the extra overhead required to encrypt this data, Microsoft suggests that it can downgrade file serving performance by up to 15%, so performance will be affected. So it really comes down to whether you favour the additional performance or the extra security. Now, the next thing we'll need to consider is whether we want to disable the default administrative shares, and there are two different types of administrative shares we'll need to factor in. Those that connect to a specific area of the Windows file system, for example, admin $, which maps to the Windows folder, which is normally located on your C drive, and drive letter $, which is an administrative share that points to each drive that you have on your system. So by default, Windows 2008 will create an administrative share for each hard drive that you have on your system. So let's go and open up a command prompt, and we'll type in net share, and we'll hit enter, and here we'll be able to see all of the administrative shares along with where they point to. So at the top here we have a share to the root of our C drive, and we'll see any other drives like D, E, F and so forth listed here for each additional hard drive that we have in our system. The next administrative share, IPC $, is a widely used share for managing named pipes. Now, name pipes are actually bits of memory that are used to handle communication that occurs between two processes. Now, when you connect to another server to perform some sort of administrative task, behind the scenes, Windows actually maps a drive, and this IPC dollar share manages this communication between the two computers. Now, you'll notice here that this one doesn't actually have a folder path like the others, and with this IPC share, you can't actually connect to it like you can with regular folders. Now, the next one, admin dollar, is like C dollar in that it's an administrative share, but rather than mapping to the root of a drive, it maps directly to the location where Windows is installed. So, if your copy of Windows Server 2008 is installed in the default Windows directory, then that's what admin dollar will map to. But is this a big deal? Well, it could be, especially if your other administrators have a habit of installing Windows in non-default directories, or if you run a bunch of Windows NT servers which by default install to the WinNT directory, mapping to the admin dollar share will always take you to the right place. So it's a good share to have for scripting as well, since that way you don't really have to know if Windows has been installed to a different folder. It doesn't matter. Admin dollar is always going to point you to the right place. Now the next one is netlogon, and that's not a hidden share since it doesn't contain the dollar sign at the end, but Windows Server 2008 domain controllers will use this share to replicate system policy and logon scripts to every domain controller in a domain. Now, when you make a change to a logon script that's stored in the sysvol folder of a domain controller, these changes are replicated to the sysvol shares of all other domain controllers in the domain. So, if the administrator manages scripts for a domain using Active Directory users and computers, then the logon scripts are typically located in the system root folder, followed by the sysvol folder, and then another folder called sysvol, followed by the name of the domain, and then a scripts folder. Now, the system will look for scripts in the netlogon share of the domain controller that authenticates the user. So the next one we have is the sysvol share itself, and again, this one's also not a hidden one. And when our server starts up, by default, it's going to create all of these shares here, whether we want it to or not. So if you want to keep these shares as they are, then you don't have to do anything at all. But if you want them to be removed, well, that's another story, so let's see how we can do it. So we'll click on Start, and we'll type in regedit, and we'll hit Enter. And then on the left, we're going to expand HKey local machine, then System, Current Control Set, then we'll expand Services, and we'll scroll down, and we'll expand LANman Server, and then we'll select Parameters. Now on the right-hand side here, we're looking for a key called Auto Share Server. Now, in my default installation of Windows 2008 here, you'll note that this key doesn't exist, so we're going to right-click and we'll choose a new dword value, and we're going to call this one Auto Share Server. And as you can see, this key already defaults to a value of 0, so we can simply close regedit and restart our server, and we'll come back in a minute. Okay, well, I've just rebooted our Windows 2008 server here, so if we go and open up a command prompt, and then we'll type in net share, and we'll hit enter. This time you'll see that the administrative shares for our hard drives and also the admin dollar share are now gone. Now, the last thing that we'll talk about in this video is encryption, although I will point out that we're not going to discuss the mechanics of implementing encryption in detail, since we'll be doing that in another video, but we will point out some of the changes that we have with encryption in Windows 2008. So the first change with Windows 2008 is BitLocker, and this was introduced in Windows Vista, and in order for you to be able to use it, it requires your server to have a Trusted Platform Module or TPM chip and a compatible BIOS. BitLocker enables you to encrypt all of the data that's stored on the Windows operating system volume, which of course is normally your C drive, and that's also going to encrypt things like your page file and any hibernation files, which I might add, hibernation files are not likely to be there on a Windows server. It'll also encrypt applications and data that's stored on the Windows volume, and you can also use BitLocker to encrypt any additional hard drives that you might have on your server as well. But in order to use BitLocker, you're going to have the hardware requirements met, which includes a TPM chip and a compatible BIOS, as BitLocker will store its encryption keys on the TPM chip if the TPM version is 1.2 or higher. If it's older than that, you'll need a USB key to store the key on, and that USB key will be needed to boot up the server. Now, the encrypting file system, or EFS, on the other hand, doesn't require any specialized hardware to work, as the encryption keys are stored with the operating system. Now, the main difference between BitLocker and EFS is that EFS is only used to encrypt files on a hard drive, and it encrypts them based on the user account that's associated with them. So, if a user called Tim encrypts files using EFS, they'll belong to him, and Bob won't be able to open them. So technically, if an attacker is able to boot your server, it's possible that they could break EFS to get access to your data. So if you're able to use BitLocker as well, you can encrypt the system drive to prevent that system from being booted, or the drive from being accessed at all if it's removed and then put into another computer. So if you're able to use both, then use both. In this video, we've looked at ways that we can further secure our file servers by implementing SMB signing to digitally sign packets to prevent man-in-the-middle attacks. We also talked about removing the default administrative shares, and finally we discussed encrypting data so that even if it does fall into the wrong hands, it's useless to whoever has it. We hope you've enjoyed this video and would like to thank you for supporting Winstructor.